Question 2.46. You are practicing throwing darts in your dorm. You stand 3 meters from the wall on which the board hangs. The dart leaves your hand with a horizontal velocity at 0.2 meter above the ground. The dart strikes the board at 1.65 meter from the ground. Calculate the time of flight of the dart, the initial speed of the dart, the velocity of the dart when it hits the board. So here you are standing 3 meter from a wall throwing dart, and this distance 3 meter is the distance of the dart along the x-axis from the wall. So I will write this distance as x equals 3 meter. The dart leaves your hand with a horizontal velocity at a height of 2 meter. So initial y position of dart is y0, which is 2 meter. And then it hits the board at a position of 1.65 meter above the ground. So final y position for the dart will be 1.65 meter. In the first part of the question, we need to find the time of flight. Now this is an example of a horizontally launched projectile. And we know in projectile motion, the x and y components of velocities are independent of each other. That means motion along the y-axis does not affect the motion along the x-axis, and we can treat them independently. So to find the time of flight, I'm going to use equations and values only along the y-axis because I know the initial y value, the final y value, and we know for projectile motion, acceleration along y-axis is equal to acceleration due to gravity, g, which is negative 9.81 meter per second squared. And for a horizontally launched projectile, initial y velocity is equal to 0. For any horizontally launched projectile, you have only initial x component of velocity, vx0. Initial y value will always be 0. So since I know all of these values along y-axis, I'm going to use equation along y-axis. So we write for part A, I'm going to use the first equation of motion, which says y minus y0 is equal to vy0t plus half at squared. Let's substitute. Y is 1.65 minus y0 is 2. Vy0 is 0. So when you multiply 0 with t, you get 0 plus half. A is negative 9.81. We need to find the value of t. So when you solve on left hand side, you get this as negative 0.35 equals negative 9.81 over 2 will give you negative 4.9 t squared. Now divide with negative 4.9 and take square root to find t. We get time t as square root negative 0.35 over negative 4.9. That gives me the time of flight to be equal to 0.267 seconds. Next in part B, we need to find the initial speed of the dart. Now the initial speed of the dart is only its horizontal velocity. That means its velocity along the x-axis. As the initial y velocity for horizontally launched projectile is 0. So my initial speed will only be vx0. So I can write for part B, we need to find vx0. We have given you the distance the dart travels along the x-axis, which is x equals 3 meter. And we already found the time of flight from part 1, which is t equals 0.267 seconds. So we will use the basic definition between speed, time, and distance to calculate this initial speed. We will write vx0 to be equal to x over t, distance over the time, which is 3 over 0.267. That gives you the initial velocity of the dart or initial speed of the dart to be equal to 11.23 meter per second. Now in part C, they want us to find the velocity of the dart when it hits the board. So we basically need to find the final velocity of the dart. Now you can find the magnitude of final velocity if you know the x and y component of final velocity. So let us first find the x and y component, then we can get the magnitude. We know in projectile motion, x component of velocity remains same. It does not change throughout the motion because there is no acceleration along the x-axis. So whatever initial x velocity we had here, Vx0, will be the same as my final x velocity, that is equal to 11.23 meter per second. So the x component of velocity for the dart when it hits the board is 11.23 meter per second, which is the same as its initial x velocity. Then we find the y component of final velocity. Y component of velocity we can find by using equation of motion. I will use the equation Vy equals Vy0 plus a into t. Let's substitute the values. Vy0 is 0, initial y velocity is 0. A is negative 9.81. Time t is the time of flight we found in part A, that is 0.267. And when you solve this, you get the y component of final velocity to be equal to negative 2.6 meter per second. After we find the x and y component of final velocity, we can find the magnitude. V equals square root Vx squared plus Vy squared. That will be equal to square root 11.23 squared plus negative 2.6 squared. Do not forget to keep the negative sign here inside the bracket. That gives you the velocity of the dart when it hits the board to be equal to 11.53 meter per second.